still being told occasionally the audio is not good or the video is not good, but mine that's saved on my computer is fine. It's when it goes up to YouTube.
It's like buffering on YouTube.
It's, yeah, or that or it's not transferring up well, so let me know if it's not recording well. Okay. But right now, if I said to you, multiply two numbers in polar form, take these. Why would you cry, Colin?
Because those are the really hard.
Well,
that way you don't yell.
thank you. It looks like that would be kind of messy. In fact, right now, how would you do it? Not because I want to learn how to do this in polar form, so you can't turn it back to rectangular. It actually, there is going to be a shortcut here, but at the moment, okay, you could distribute the 2 and the 5. I wouldn't. Instead, I would go, hey, I got these numbers out front. Yeah. Can I put the 10 out front? Okay. But then, how do I do the quantities in the parentheses? Right now, our only choice would be to FOIL them, which we're going to do right now, but then we'll find a better way in a moment. So in this case, when I take cosine of 30 times cosine of 70, can you do that? Can you add the angles? Because like cosine of 30 is square root of 3 over 2, cosine of 70 is some totally other number. You can't just combine them somehow. So, no, you would be stuck with cosine of 30 times cosine of 70. No, because they're not the same. Square means to take it times itself. They aren't the same, so no, you can't combine them. So then, outside, those aren't the same. So I'm just going to write all this down is basically what's going to happen. And there's going to be a formula here in a moment. Inside's another I with a sine 30 and a cosine 70. And then, okay, last you have to watch. You got an I times an I. That's going to be an I squared. And then I've got sine of 30 and sine of 70 are two different values, so they're still sitting there. Okay. What can I do with I squared?
You can make it into a -1.
We know I squared is -1, so I can cancel it off. You can't see that. I can cancel it off and make it a minus now. Okay. That is a ton of terms. But does it kind of look like a familiar pattern you've seen somewhere before?
Wait, why'd you cross it off? Is it like a square root?
Because I squared is -1, so I'm changing it to -1.
That's one of the identities.
That's the powers of I. Remember, I squared is I1 with two negatives in the middle. I squared is -1. Okay, but there are identities, and you're right. It's the A plus B identity. If you look at the back side of the yellow sheet, but these aren't grouped in the right order. Is there one of those identities that starts out cosine 30, cosine of 70?
Yeah.
Okay, what does it have to finish with?
Sine.
It has to finish with a sine. Well, do we have a sine somewhere?
Like that.
Down here on the end, we have a sine. So I would have a cosine times a cosine minus a sine times a sine. And that then is the cosine of A plus B identity.
It's crazy.
Okay, so in our case, what are A and B? 30 and 70. Okay, so those two, the two with the green underlines became this. That's better. Okay, so the two that aren't underlined, so I make them black. Do we have an identity that has a cosine times a sine plus a sine times a cosine?
Yeah. It's the
Go ahead and say now on S, you better give it a
plus that'd be
Okay, you aren't going to have to do this because we're about to find the shortcut.
sine A.
Okay, so it's the sine of, on sine to sine, it's A plus B. So they noticed they both ended up being A plus B. Now, what do I do with the I? Yep, you just pull the I completely to the front and let it sit there. So I would have 30 plus 70. Okay, so now, can't I add those angles together? They're in the parentheses together.
Yeah.
So basically, you made another complex number.
Exactly, Adam. I just made another new complex number in polar form. Okay, so now, find me the shortcut.
Just add the cosine, the two cosines together, and that's the...
It's how do I get from here to there without doing all that middle stuff?
Take the 2 times the 5, the cosine times...
Yeah. The R's, the numbers in front, we multiplied. And the angles,
Add them.
we add them. That's all it takes.
And that's the answer?
That's the answer. That 10 cos, yeah, if they want you to do it polar form, yeah, so all you have to do is multiply the R's, add the angles, and you're done. You don't have to do all that work.
Wow.
See, that's better news. Okay, I asked you to write these formulas somewhere on your journal. Okay. You have to, however, write out both sides here, so it's kind of a pain to write it out. But if you have the general formula, I'm going to put subscripts of 1 on the first complex number, and then I'm going to put subscripts of 2 on the second complex number. You have to have this part with it, or otherwise it doesn't make sense. I always have people who just want to write the answer part. Okay. Since I'm out of space, what does that equal? What we just discovered was the rule here.
Equals all times.
What do you do to the R's?
R2.
Yes, you multiply the R's. R1 times R2.
Then cosine angle 1 and 2 add together.
Cosine of angle 1 plus angle 2. I can't. So all this is just a fancy way to write it out and say, multiply the R's and add the angles.
R1, R2. Did we get another journal? So now I have 2 journals?
Oh, did you not get, you were here the other day. Yeah, you got a new journal for just this little section.
This is peach color?
Yeah, this one's peach. This one's that light peach. Okay, so that's the rule. It's a big, long, messy rule, but that's the rule. Multiply the R's, add the angles. That's all you got to know.
All we got to know then.
That's for multiplying. So now, if I throw you a problem that looks hideous,
I'm going to hit it. Hit the wall.
ready to march.
Probably doing a Hitler or
Okay, so if I say take this complex number times this complex number, if I say multiply those two together, you look at it and go, oh, no problem. My answer is going to be what? Multiply the R's. The radius is out front, so 60. Yeah, you're just going to multiply your R numbers in front. You're going to add your angles, and I'll buy Devon's 355, and you're done. They're that hard to multiply. No, that's not all we're doing today.
That should be all we're doing.
And then do it in rectangular, that would be complicated.
And yeah, to do that rectangular would actually be more work than it is to do it here. Okay, this is going to lead to a bigger. You're going to make something else that would be horrible in algebraic form become much simpler. So you're going to remember that rule. Okay, I also now think I'm going to bet you can figure out the rule for dividing if you know the rule for multiplying.
So you can divide minus, right? Divide the base and...
So if I give you a complex number divided by a complex number,
L1.
okay, you want to do what with the radius? What are you going to do to the R's? Divide them. If we multiplied the R's, you're just going to divide them. And then, what are you going to do to the angles? Subtract them. Which one minus which one? It's actually a matter of which one, where they're located. What would be the logical way to subtract them?
So 1 minus go to.
Yeah, it's gonna be the top one minus the bottom one. So you're gonna do cosine of angle 1 minus angle 2. So it's the sine of angle 1 minus angle 2. Since you're dividing, you will subtract those angles. So let me throw you an amazingly difficult...
You forgot your eye.
Ah! You're right, I did. I won't be able to see well if I lose my eye.
Yeah, that's good.
Okay, so if I give you a problem such as this, divide and change to rectangular form, what does that mean your answer has to look like? It's got to be back in rectangular form. What does it mean if it's in rectangular form? What's it going to look like? Yeah, number minus something I, number plus something I. So it's going to be back to an ordinary complex number. It's actually the most trouble just to write it out.
We have a quiz and should follow off this, right?
You have a quest on this on Monday.
We don't need to copy it then, if that's the hardest part.
Okay, so what's the rule say when I divide that? What do I do with the front numbers? Divide them. So 15 divided by 5, we get 3. What do I do with the angles? We subtract them. Okay, and you have to do top minus bottom, so you will get a negative here. So that will give you negative 210 plus I sine of negative 210. Okay. Yes, the angles have to be the same, always. If you are in polar form, you must have the same angle in both places. You cannot have different angles. That would be incorrect. Impossible. Okay, on this one I said and convert to rectangular form, but I do want to talk about, if I had said leave your answer as polar form, if I had said leave it just like this, they do not leave negative angles in the answer. So do you remember those little rules? They're right below your fundamental identities that tell you what to do with negative angles. Cosine just drops its negative, sine pulls its negative to the front. So if we were stopping here, they would make you change this, and you would change cosine of a negative angle is exactly the same thing as cosine of the positive angle, but sine, we pull the negative out front. And it's all about whether cosine is an even function and sine is an odd function. That's why all that happens. But if you were stopping, you would stop there. Yeah. This one said change it back to rectangular form. So how do I change it back to rectangular form? 210 is a special angle. So yes, you would draw the picture and go, oh, 210. I believe that's 30-degree reference angle. So cosine of 30 is square root of 3 over 2. And this is where I'm going to finally get you all to learn this. If cosine is square root of 3 over 2, what is sine? A half. If one of them is a half, the other one is square root of 3 over 2.
Yeah, no.
They're opposite.
This one is 45.
Yeah. And then, yes, you would have to worry about your that's the number one thing that'll cause you... Excuse me back there, male voices that are rumbling. 210 is the third quadrant. Oh, yeah, okay. Yes, this will become negative. This will become negative, so that will, yes, make that a plus.
No, because you copied down the wrong one. You changed it. It would be positive.
So now, yeah, the two negatives will make a plus, yes. Okay. I just haven't gotten there yet.
The first one, the very top answer above that middle one, is positive. And then you changed it to negative because we thought we were stopping there, but shouldn't we keep it positive?
Well, okay, it's still going to be the same answer. Because if it wasn't, then changing it wouldn't be an equivalent answer. Negative 210 is backwards 210. It's second quadrant. Cosine is still negative in the second quadrant. It's still going to work. Whether you worked it this way or you worked it this way, you're still going to get those exact same numbers. It is the same answer either way. Otherwise, it would be invalid to do it because it wouldn't be giving the same values. Now, they will distribute the 3. So you would, in the end, then just make that 3 square root of 3 over 2 plus 3. They'll probably just write it 3i over 2 since it's not a square root.
How'd you get that angle again?
What angle?
On the drawing?
How'd I get this one or this one? This one we actually did using 210.
Okay. And you just went around.
This one, if you hadn't changed the sign, gotten rid of the negative, you could have done it here. Negative 210 just meant you went backwards 210. You would got the same reference angle, you still get the same values. So it doesn't matter if you can. Doesn't matter if you're working it on down. It doesn't matter whether you work it with the positive or the negative angle. You'll get the same answer.
16 minutes.
Oh, gotcha. I'm going. No, I got 25.